Hello everyone. Today we will discuss about the generation of amplitude modulation. In this lecture we will discuss about the generation of amplitude modulation using diode and transistor, and at the end of the lecture we will discuss about the demodulator circuit using diode. In previous lecture we have discussed about the separation of the carrier and a sideband, that is single sideband, and the importance of the separation of carrier and sideband. At the same time we have discussed about the vestigial sideband transmission. Now in today's lecture we will discuss the first method of generation of amplitude modulation by using diode. As you know, the amplitude modulated signal is the product of two signals, that is 1 plus modulation index into the cos of omega m t and cos of omega ct. So where cos of omega ct is the carrier signal and 1 plus ma cos of omega mt is its amplitude. To generate amplitude modulation, we can multiply the carrier by a factor that varies with modulating signal. Another way to generate amplitude modulation is mixing linearly or adding algebraically the carrier and the modulating signals, and then apply the composite signal to a non-linear device or circuit. In diode modulator, let us discuss in detail about the diode amplitude modulator. This method is the simplest method to generate amplitude modulated signal. It is shown in figure, that diode modulator. It consists of a resistive mixing network, a diode rectifier, and LC tuned circuit. The carrier is applied to one input resistor and the modulating signal is applied to other resistor. The modulating signal and carrier gets mixed and appears across R3. If carrier and Modulating signals are sine waves as shown in the figure. Let that figure. So the modulating signal, as you know, low frequency signal, and carrier signal is the high frequency signal. So we can draw these two signals. The first is the modulating signal, this is the carrier signal. Okay. And this resultant waveform is found across R3, and that will be as shown in this figure. It will be, so whenever the in positive half modulating signal, so you will be find that this variation in the amplitude of the carrier will be varied like this. So this is the sum of the carrier and modulating signal. The two signals get mixed and modulated, since modulation is a multiplication process, not addition. The diode functions as a rectifier in this circuit. The composite waveform, as shown in the figure 3, this figure, is applied to the diode. The diode gets forward biased by the positive going half cycle of the input wave, and during the negative part of the wave, the diode is reverse biased. The current through the diode is in the form of positive going pulses, and its amplitude varies according to amplitude of the input wave, or in turn amplitude of the modulating signal. So the current through the diode is more than when modulating signal amplitude is more. These positive going pulses are applied to the parallel tuned circuit consisting of L and C. Values of L and C are so chosen that they resonate at carrier frequency. The LC circuit generates the carrier, and each time when the diode conducts, a pulse of current flows through the twin circuit, and the amplitude of the pulse generated by LC circuit increases. The amplitude of waves generated by LC circuit is decided by current through the diode, which in turn is decided by amplitude of modulating signal. So, the waveform across the tuned circuit is the amplitude modulated as shown in the figure like this. So, in this case, this is the diode current, and that will be the maximum will be at the time of, that is, this is the diode current, and the amplitude modulate modulated output through the LC circuit is given by this last waveform. So this is the amplitude modulated waveform will be observed here. As you know, the amplitude modulation is nothing but the amplitude of the carrier is varies according to the amplitude of the modulating signal. So here in the last figure, it will be the amplitude modulated signal across the tune circuit. Okay, now let us discuss the amplitude modulation using transistor. There are many circuits to obtain amplitude modulation. The circuit for generation of amplitude modulated waveforms must produce the product of the carrier and modulating signal, and this can be done by biasing a transistor for non-linear operation. The circuit diagram of a modulator using transistor is shown in the following figure. The circuit utilizes the amplitude of the audio signal to modulate the amplitude of the carrier signal. The circuit will require two signal generators. One of these is the RF carrier and other to generate audio signal. The two signals are mixed and amplified by the transistor, and the amplitude modulated signal is generated at the collector of the transistor. When no modulating signal is present, the circuit operates as a linear amplifier. The output is simply the carrier amplified by the transistor. When a modulating signal is applied, the amplifier operates non-linearly and signal multiplication occurs. The modulating signal varies the gain of the amplifier at a rate equal to the frequency of the modulating signal. So this circuit generates amplified carrier whose amplitude is a function of amplitude of the modulating signal. For the circuit shown above this circuit, amplitude of the output signal depends upon amplitude of the input carrier and the voltage gain of the amplifier. The modulation index of generated amplitude modulating signal depends upon amplitude of the modulating signal. Now we shall discuss about the demodulator circuit using diode. So in the first figure it is shown that amplitude modulated signal is given to the circuit input as inputs to the circuit, and the output is the obtained is a modulating signal. It operates by detecting the envelope of the incoming signal, which it does by rectifying the signal. So in the block diagram we can see the rectifier, and here the diode half-wave rectifier is used. The current is allowed to flow through the diode in only one direction, giving either positive or negative half of the envelope at the output. If the detector is to be used for audio detection, it does not matter which half of the envelope is used. Either will work equally well. When detector is also used to supply the automatic gain control circuitry, will the polarity of the diode matter? The amplitude detector or demodulator includes a capacitor at the output. Its purpose is to remove any radio frequency components of the signal at the output. The value is so chosen so that it does not affect audio baseband signal. This is all for today's lecture. In next lecture, we will discuss about the amplitude modulated receivers.